Welcome back, everyone, to the Architecture Corner. And this is it, the final part of our big series looking into AWS messaging solutions.
That's right. We've gone through SQS, SNS, EventBridge. Quite the journey.
Definitely. We unpacked queues, notifications, event buses, and now we're setting our sights on something a bit different, Kinesis.
Yeah, Kinesis is really its own beast, focused squarely on, well, streaming data. It's crucial for anyone looking at decoupling and managing data flow, but it approaches it from a unique angle.
An angle focused on data in motion, right? Not just messages passed and deleted.
Exactly. It's about how Kinesis keeps applications connected and that data flowing continuously. So let's get into it.
Okay, so maybe let's quickly recap. SQS, SNS, EventBridge, they often decouple by having producers send messages, consumers pick them up, process them, and often they're gone, removed.
Correct. Kinesis takes a fundamentally different path, specifically Kinesis data streams, which is our main focus today. I mean, the Kinesis family also has data analytics and Firehose, which are super interesting too, but data streams is the core streaming part, often compared to Kafka.
Right, Kafka comes up a lot. So what's the key difference with data streams?
The data persists. The same message, the same record stays in the stream and remains available to multiple consumers even after it's been processed by one.
Ah, okay, so think of it like a river. Everyone downstream can see what's floating by, and it doesn't just vanish once the first person sees it.
That's a great analogy. It's a continuous flow, and that persistence is a hallmark of streaming solutions. It allows different apps to consume at their own speed, maybe even reprocess data later.
And multiple producers can feed into this river.
Absolutely. Multiple producers add data, it flows through the stream, and then various consumers can tap into it for whatever they need.
Okay, let's break that down. What are the pieces? You mentioned data records.
Yeah, the data record. That's the fundamental unit. Your piece of data, your event, your message. What's interesting is Kinesis itself doesn't really care about the format. It just treats it as a base 64 encoded blob.
A blob. So flexible on the data type then. But each record needs something specific, right? A partition key.
Crucial. Yes, every record needs a partition key. Kinesis uses this key, essentially hashes it to figure out which specific storage location within the stream the record should go to.
Like an address or a lane assignment on the highway?
Pretty much. It ensures related records, say everything for one user, often end up in the same place for ordered processing later.
Got it. So the key guides the record. And these records live inside shards.
Exactly. A stream is made up of one or more shards. You can think of a shard as an ordered sequence of data records, like an individual lane, as you said. And each shard has its own specific capacity limits. For writing data in, it's up to 1,000 records per second, but capped at 1 megabyte per second total.
Okay, 1 MB/sec write per shard. And reading.
Reading from a shard, you can make up to 5 requests per second, pulling out a maximum of 2 megabytes per second. Understanding these is key for sizing things right.
Right, avoids bottlenecks. So shards are the lanes. The data stream is the whole highway then.
Perfect analogy. The data stream is the ordered collection of all the data records distributed across all its shards.
And how long does the data stick around on this highway? Does it just flow off the end eventually?
Well, by default, it's retained for 24 hours, but you can configure that, keep it for up to a whole year if you need to.
A year. Wow, okay.
Yeah.
That's serious persistence. And how many shards, how many lanes can we have?
A single stream can have up to 499 shards currently. And you can adjust this number, scale it up or down based on your needs. But here's a key point. Scaling shards isn't automatic like some managed services. You actually have to trigger it manually.
Ah, okay. More hands-on control there, which might be good or bad depending on your setup.
It means you need to monitor and plan capacity.
So how do we estimate how many shards we do need? Is there a guideline?
Yes, AWS provides a formula. It's basically number of shards, max, incoming write bandwidth KB1024, outgoing read bandwidth KB2048.
Okay, let's unpack that slightly. It looks at both incoming write speed and outgoing read speed.
Exactly. It considers your producer write bandwidth, which is roughly your average record size times records per second, and your consumer read bandwidth, which is essentially the producer bandwidth multiplied by how many consumers you have reading.
Right, so if you take that example, 800 records a second, 5 KB each with 3 consumers.
Plugging that in, yeah, you calculate the write need, 805, 1024, 3.9, so let's say 4 shards needed for writes. And the read need for ME-3 consumers do ME-sec shard equals 6 shards for reads. You take the max, so you need about 6 shards based on that formula. Oh wait, the source example said 12. Let me recheck that calculation. Incoming is 800 rec-sec, 5 kbrac equals 4,000 kbsec. So 4,1024 equals 3.91 shards needed for ingest. Outgoing is 4,000 kbsec for 3 consumers, 12,000 kbsec total read bandwidth needed. So 12,2048 equals 5.86 shards needed for egress. The max is roughly 6 shards. The source said 12. Maybe there's a nuance or safety margin they added. Let's stick with the formula's result for now, around 6, but acknowledge the source suggested 12, perhaps anticipating growth or peak loads.
Okay, good to know the formula gives a baseline. Always smart to add headroom anyway. So we have the stream set up. How do applications actually write data to it?
It's pretty straightforward for producers. They need the stream name, that partition key we talked about, and the record content itself. You use the put record API call, and the response tells you the sequence number, its unique position, and the ID of the shard it landed in. Kinesis uses that partition key hash to pick the shard, remember?
Put record, one at a time. What about bulk writes, if I have lots of data coming fast?
Good question. For higher throughput, there's the put records API. It lets you send up to 500 records in one go. There are limits, of course. Each record up to 1 millibead, the total request size up to 5 millibead.
But there's a catch, similar to EventBridge, right, with batching.
Yes, exactly. If some records in a put records batch fail, maybe due to throttling or an internal error, the whole batch doesn't necessarily fail. Some might succeed, some might fail.
Which could mess up ordering if you're not careful.
Potentially, yes. The response tells you exactly which records succeeded with sequence number and shard ID, and which failed, giving you error codes and messages. So you need robust error handling on the producer side. Understanding those common Kinesis errors is really important.
Okay, producers are writing. Now the other side, consuming, getting the data out. Sounds like it might be more complex.
It is a bit more involved than, say, pulling from an SQSQ. You need to specify the stream, the specific shard you want to read from, and where in that shard to start reading the starting position.
That sounds fiddly. Is there help?
Definitely. AWS provides the Kinesis client library, the KCL. It abstracts away a lot of that complexity. It handles things like checkpointing, keeping track of how far you've read in a shard so you don't reprocess or miss data. And it also manages things like reacting to resharding events gracefully.
KCL. Okay, the helper library. But what about serverless, if I'm using Lambda?
Well, that's often the easiest path for consumption in modern architectures. You can configure Lambda as an event source for a Kinesis stream. In that setup, Lambda basically manages the KCL requirements for you. It pulls a stream about once a second, grabs a batch of records, and invokes your function with that batch.
So Lambda does the heavy lifting of polling and batching. Nice. Any tips for using Lambda with Kinesis?
Yes. Enable custom checkpoints if you can. It gives you finer control over error handling within a batch. Instead of Lambda maybe retrying the whole batch if one record fails, you can potentially mark just the failed records for reprocessing later, depending on your function logic.
Makes sense for precision error handling. Okay, now scaling. What if my data volume explodes, or I suddenly need way more applications reading the stream?
Right, common scenarios. You need strategies. The most basic one is just adding more shards. Since each shard has fixed capacity, adding more shards increases the total throughput of the stream for both reads and writes. This triggers that resharding process we mentioned.
And how does that affect existing consumers?
They typically finish reading all the data from their assigned old shards before they start pulling from the new shards created during the reshard. This helps maintain processing order within the original shard's data.
Okay, so add shards for more overall throughput.
Wow.
What if the stream has enough capacity, but my individual consumer, maybe my Lambda function, can't keep up with the data coming from its assigned shard?
Good point. If one consumer is the bottleneck for a shard, especially with Lambda, you can use parallel consumers per shard. Lambda lets you configure up to 10 concurrent function invocations per shard.
10 parallel Lambdas reading from the same shard. How does ordering work then?
Well, Lambda ensures that all records with the same partition key within that shard always go to the same concurrent invocation instance. So, order is preserved for related records.
But if my partition key isn't very diverse, if lots of records have the same key,
then you might not get much benefit from parallelism, exactly. That specific invocation instance handling that popular key could become a bottleneck itself. This is why monitoring the iterator age metric is so vital. It tells you how old the data is by the time it gets processed. If that age starts creeping up, your consumers aren't keeping up. You might need more parallelism, or you might need to rethink your partition key strategy to spread the load better.
Iterate age. Got it. Key metric. Now, what about pure speed? What if I need really low latency, maybe for real-time dashboards or something?
For those latency-sensitive applications, especially with many consumers or high bandwidth needs per consumer, Kinesis offers enhanced fan-out, or EFO.
Enhanced fan-out. What does that do differently?
Standard shard consumption shares the 2 millibsecond read bandwidth among up to 5 consumers, and the latency can be anywhere from, say, 200 milliseconds up to a second due to that polling mechanism. EFO changes the game. It gives you up to 20 dedicated consumers per shard, and each gets its own private, non-shared slice of bandwidth. The latency drops dramatically, typically averaging around 20 milliseconds because Kinesis pushes data to them.
Wow, 20 milliseconds. That's fast. But I assume there's a cost.
Yes, EFO is an add-on feature with its own pricing model based on consumer shard hours and data retrieved. It's a premium option for when that low latency and dedicated bandwidth are critical.
Makes sense. Pay more for premium performance.
Okay.
Okay, we've covered SQS, SNS, EventBridge, and now Kinesis. That's a lot of messaging options. How do you even begin to choose the right tool for the job?
It can feel overwhelming, and honestly, as systems grow, you'll probably use a mix of them. It's less about hard rules and more about heuristics using your application's needs to guide you.
Okay, heuristics. Let's try some. What if I just need one app to tell another app to do something? A direct command.
Simplest case, almost always direct SQS. Point-to-point, reliable, keep it simple.
Okay. What if multiple applications need the same piece of information, that fan-out pattern?
Right, now it gets interesting. SNS, EventBridge, Kinesis are all contenders. You need to ask more questions.
Like how many destinations?
Exactly. If you have a massive number of subscribers, potentially unknown consumers, SNS is often the best fit with its published subscribe model. If it's a smaller, known set of consumers, say 5 or fewer, EventBridge and Kinesis are definitely viable. Then other factors come into play.
Such as filtering. If I only want consumers to get certain messages.
Yeah, SNS filters on message attributes. EventBridge offers much richer filtering based on the entire message content, the event payload itself. Kinesis doesn't really do filtering at the stream level. Consumers typically filter what they pull.
What about needing to replay or reprocess messages? Maybe for analytics or if a consumer had a bug?
Kinesis is a very strong candidate there because of that data persistence we talked about. You can go back and reread the stream for up to a year.
Good point. And integrations, especially with third-party services.
EventBridge often has the edge there, particularly with its growing number of AWS partner integrations through event sources and API destinations.
Okay, final factor maybe, latency, if speed is critical.
Generally speaking, SNS tends to have the lowest average latency. Kinesis, especially with EO, can be very fast too. EventBridge usually has slightly higher average latency than SNS or EFO Kinesis.
So it really does boil down to understanding your specific needs.
Yeah.
Number of consumers, filtering requirements, reprocessing needs, integrations, latency sensitivity.
Precisely. Ask those questions about your application, and the best choice or combination of choices usually becomes much clearer. It's about matching the tool to the specific problem you're solving.
Well, this has been fantastic. As we wrap up this final part of our series on AWS messaging, we've really seen how Kinesis provides this powerful, stream-based way to handle decoupling and high-velocity data.
Yeah, that ability to have persistent streams for multiple consumers really unlocks a lot of possibilities for analytics, complex event processing, you name it.
Absolutely. We hope this look at Kinesis, along with our earlier explorations of SQS, SNS, and EventBridge, gives you a clearer picture of the diverse toolkit AWS offers for building resilient, scalable systems.
Remember, the best choice always depends on your specific application's needs and characteristics.
Couldn't agree more. And hey, if you want more details or want to revisit any of this, do check the description. There's also a link there to subscribe for free to the Architecture Corner newsletter for more content like this. Thanks so much for joining us on this architectural exploration.